Hello students, I'm going to teach you physics. Myself is Sunana. So let's start today the first lecture with mathematical tools. Now first unit is physical word and measurement, but we are not going to start that directly. Before that we are going to do mathematical tools. Why so? Why we require mathematical tools? Because in this subject physics you are going to deal with number of equations, number of formulas, and even when you are going to solve the numericals, then you need number of tools like formulas, like binomial theorem, graph, how to use different things. So that's why we are having first look on this, how we can use it, what's the use of this, what these things actually are. Only then you are able to use this while doing the numerical. So let's start. In mathematical tool, we are going to discuss about algebra, graph, trigonometry, logarithm, function and limits, differentiation, integration, and some general rules. So we are going to discuss in detail about the first section of mathematical tool, that is algebra. Now algebra, what we are going to do, we are going to discuss about the common formula that you already had used in class 10, quadratic equation. You are also aware of this. And third one is binomial theorem. This part is new to you. What plus? This is actually new to you all, but this two you already had done in class 10. So let's start with common formula. So now we are going to discuss about the common formulas of algebra. But they are too much in number. So we are discuss about some 8 formulas here. A plus b whole square, that is a square plus b square plus 2ab. A minus b whole square, a square plus b square minus 2ab. And a plus b plus c whole square. This is the formula that we already had used in class 10th. So a plus b, a minus b, that is a square minus b square, a plus b whole cube, a cube plus b cube plus 3ab, a plus b with minus sign, then we have a minus here and minus here and here. And a plus b whole square minus a minus b whole square, that is 4ab. But if we have a plus sign in between, then we get 2a square plus b square. So these are the common formula of algebra. Now next is quadratic equation. Quadratic equation, the general form of quadratic equation is a x square plus b x plus c is equals to 0, where a, b and c, these are the constants and x is the variable. And I hope you already know about what are variables and constants. Now, what's a quadratic equation? It's an equation with a maximum degree of 2. Maximum degree is 2. What's a degree? It's actually the power of a variable. This is variable x. The maximum power of this variable is 2. So it's for this equation degree is 2. For it's a second degree equation. So it's a quadratic equation. Now next is roots, zeros, and solution of equation. This 3 words sounds to a same meaning: zeros, roots, or solution of an equation. What these are? These are actually value of x. That values of x which once substituted in the equation, this left hand side also become 0 or satisfy the equation. Say we having the value of x is equals to 3. Let's say, and when we substitute x 3 here, so it is 9a, that is 3 square, that is 9a plus 3b plus c. If we solve this by substituting the value of a, b and c, and this side come out to be 0, then that value of x, that is equals to 3, is the solution, or we can say root, or we can say 0 of this equation. So 0, roots, or solution, these actually are that value of variable which when substituted in the equation satisfied this equation. Now there are, as it is a quadratic equation with a degree of 2, so it has 2 solutions. So this equation has 2 solutions. For a linear, if we have a linear equation, means with the degree of 1, for that we have 1 solution. But this is a quadratic equation with a second degree, means power of 2. So there are two solutions or two roots or two zeros. So let first be alpha and second be beta. Let alpha and beta be the roots or zeros or solution of equation 1. So alpha is equals to minus b plus under root of b square minus 4ac upon 2a, and beta is equals to minus b minus under root of b square minus 4ac upon 2a. This formula you already had used in class 7. Now next is alpha plus beta is equals to minus b by a. This is called sum of zeros. Sum of roots or zeros, that is always equals to what? Minus of coefficient of x upon coefficient of x square, and product of roots or product of zero, product of roots or product of zeros, that is equals to coefficient or a constant upon coefficient of x square. In this equation, if we check for the coefficient of x square, x and the constant, this is x square, a is the coefficient of x square, this a is coefficient of x square, this b is coefficient of x, and this c is a constant here. So that's why this is coefficient of x with a minus sign. Minus sign, coefficient of x is b upon coefficient of x square, that is a. Product of root, that is constant, constant is c. Coefficient of x square is again a. And difference of root, that is alpha minus beta, is equals to under root of b square minus 4ac upon a. We can also find this by using these two formulas. To write this for you. Now alpha is minus b plus under root of b square minus 4ac upon 2a. Beta is minus b minus under root of b square minus 4ac by 2a. You know b is what? This is coefficient of x. This a is what? Coefficient of x square. C is a constant. So first of all, alpha plus beta. When I substitute the value of alpha and then beta, and by opening this bracket and separating the LCM, we get minus b by 2a plus under root of b square minus 4ac by 2a minus b by 2a minus under root of b square minus 4ac by 2a. Now this both get cancelled because one is positive, other is negative. This both minus b by 2a, minus b by 2a. So it is minus 2b by 2a because minus minus plus. So my 2 gets separated, get divided with this 2. So we get minus b by a. So alpha plus beta is minus b by a. This is equal to. Now alpha minus beta means this is alpha minus, instead of plus we will take here minus. So again separating the LCM, minus b by 2a plus this. Now here instead of plus we will have minus sign. So minus minus plus, minus minus plus. So we get here plus b by 2a plus this term. This is of minus, this is of plus, again get cancelled with each other, and this last two term plus plus plus. So they get added up and with get multiplied with the factor of 2. 2 get divided with this 2 or get cancelled with this 2. So we get alpha minus beta equals to under root of b square minus 4ac by. Next is alpha into beta. So by substituting the value of alpha and beta. Now what I am going to do? Minus, minus, I am taking minus common here. If I take minus common, then it's also become plus, it's also become plus. So we can also write as 2 plus 3 or 3 plus 2. Is there any difference? No. If I have 2 minus 3, or I can also write as minus 3. Oh, sorry, we have minus 3 plus 2. We can also write as 2 minus. So the same I am going to do here. I am taking minus b here and plus under root of b square minus 4ac in front. Taking minus sign common here. This is here. So this both become of positive. And I am writing this term firstly and this second. So this is a minus b. If I take 1 by 2a by 2 common from here, so I get 1 by 2a whole square because 2a into 2a, that should multiply. Now this is a plus a minus b, a plus b, by using the formula a minus b, a plus b, that is a square minus b square. So this is complete is a, so a square minus b square. As square get cancelled with this root, we will get b square minus 4ac, and this is minus b square. Minus b square get cancelled with minus b square, and in last we get minus 4ac. So minus minus plus 4 get cancelled with this 4. A square with a, we only left with c by 8. So alpha plus beta is what? C by 8, that is constant by coefficient of x square. Now next is binomial theorem. Binomial theorem, we will do it for the two. One for the positive integral index and second for any index. Positive integral index means we are taking index for, we are taking this n as an index here. If this n is positive, means a positive and integral value like 2 plus 5 plus 100, like this is the positive integral. For any other index means this n has any value other than the positive, like minus 2, like minus 1 by 5, 1 by 8. So these are any other indexes. So let's first do it for the positive integral index. Positive integral index means n is going to be a positive integer here. Index, we are taking this power as an index. And if we are taking it as positive integral, so n is here positive integer. So that's why we are saying positive integral index. Where x and a binomial, this is for bi means 2. Bi means 2. So it's for 2 terms. Binomial means for 2 terms. So x plus a raised to power n, where x and a both are any real number. Now there is a binomial theorem formula, that is nc0 x raised to power n a raised to power 0 plus nc1 x raised to power n minus 1 a raised to power 1, so on, and cn x raised to power 0 a raised to power n. Now what's happening in this formula? We start from n. C is combination here. Later I will discuss what's the meaning of C here. This is O. Starting from very zero term O. First term, this raised to power n. Second term A, this is 0. Next, this 0 is going to increase to 1. So NC1. So this power is going to decrease by 1, and this power is going to, its power is going to increase by 1. So it's, if we decrease it by 1, that is x raised to power n minus 1, this is a raised to power 1. Next, NC2. This means x raised to power n minus 2 and a raised to power 2. So we are starting from 0, 1, 2, 3, we have go to what? This maximum value. So n, this is x raised to power n minus n. This is n minus n is what? 0, and here a raised to power n. Now binomial coefficient. Binomial coefficient. NC0, NC1, NC2, this all terms. These are called binomial coefficients. Now what is the, let's take a general binomial term, that is NCR. Its formula, how we can solve it, this is n factorial upon r factorial n minus r factorial. This is the formula of it. Or we can say it as factorial n. What's the meaning of this? N factorial. We can read it as factorial n or n factorial. This is also the symbol of factorial. So factorial is represented by two symbols, one by this sign, and second by this sign, like angles exponential. So n factorial, this is n factorial also. Now how we can solve n factorial? So NCR, the formula is n factorial, means this term factorial upon r factorial. Subtract these two terms, what is the remaining? We have to write here n minus r factorial, or we can also represent as n factorial of this, r factorial n minus r factorial. Now I am going to describe you what is factorial and how we can solve that. Now I am going to tell you about n factorial. We can write it as n minus 1, n minus 2, so on up to 1. What it means? Let's do it for a little bit simple way. Let me have 5 factorial. 5 factorial means 5. 1 less than 5, that is 4. 1 less than 4, that is 3. And again 1 less 2, and last 1. So it's 5, 4, 3, 2, 1. Suppose I have here 12 factorial. So it is 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2 and 1. Up at 1 we have to stop. We don't have to go further because then it becomes negative. Now NCR, we are going to compare it with 5C2. Suppose I have the binomial coefficient 5C2. So N is here what? 5, CC, R is what? 2. So N is 5, R is 2. As a general formula for NCR is N factorial upon R factorial N minus R factorial. So 5C2 factorial formula is 5 factorial, 5 minus 2 factorial into 2 factorial. So 5 minus 2, that is 3. So 5 factorial, 3 factorial, 2 factorial. So 5 we can 5 factorial inside. We can write 5, 4, 3, 2, 1. Now this is what? 3, 2, 1. This is 3 factorial. So again I also write it as 4 into 5 into 4 into 3 factorial upon 3 factorial into 2 factorial. 3 get cancelled with this one. So at last we are left with 5 into 4 upon 2 factorial. So 2 factorial is 2 into 1. 2 get cancelled with 4. We get 10 here. So the value of this binomial coefficient is 10. So N5C2 is 10. Now I am going to tell you about the general terms. Now if we have NC0, we are going to solve for this general term, and NCN you will try it by yourself. Its value is 1. Now first start with NC0. The formula is N factorial upon N minus R factorial. This is N, this is R is here 0 into R factorial, that is 0 factorial. Always remember this thing that 0 factorial is equals to 1. So we get here N factorial. N minus 0 is N factorial again. And instead of 0 factorial, we write here 1. So N factorial by N factorial, that's going to be 1. Because both get cancelled with each other. Now for N, so we get NC0 is equals to 1. NCN, you are again going to solve it by, you have to solve this by yourself. Here N is N, R is N. Try the formula and try to get answer this equals to 1. Now NCN minus 1. N factorial, N minus R factorial. N minus this R factorial into R factorial. If I open this bracket, plus minus minus, plus minus minus plus. So N get cancelled with N, so we again get 1 factorial, N minus 1 factorial. So if we open this N factorial, we are going to expand this N factorial, that is N minus 1, N minus 2, so on up to 1 upon N minus 1. So this N minus 1, N minus 2, this is what? N minus 1 factorial. So again I am going to write it as N minus 1 factorial. So N minus 1 factorial get cancelled with N minus 1, so this is N. So N Cn minus 1 is equals to 1. Similarly, for NC this is also again going to be N. You have to prove this by yourself. So by this general formula, what can I say? So if we have 5, so I have a binomial 2 plus 3 or 2 plus 1 or say 3 raised to power 2. Here A, X and A are real number and is positive integer. So we are going to use the back formula, that is, what's the formula was? N, that is 2, C0, X raised to power N, that is 2 raised to power 2, A raised to power 0. Something raised to power 0 is always 1. So 3 raised to power 0 is going to be 1 here. Plus NC1, we are going to, that is 2C1, 2 raised to power 1, because we are going to subtract 1 term, 2 minus 1, 1, 3 raised to power 1, it's going to be raised by 1. So 2C2, that is NCN, we have to show here. That is 2 raised to power 2, 0, and 1 minus 1 is 0, 3 raised to power 2. Then this term is again 1. So we get here 2 plus 3 raised to power 2 is equal to 2C0, 2 square, this term is going to be 1, plus 2C1, 2 into 3, plus 2C2, this 2 raised to power 0 is going to be 1, this is 3 raised to power So now 2 plus 3 square, we get this 2C0 is equals to 1 and 2C2 that is also equals to 1. How we can get this? By using this general formula NC0 and NCN is 1. I can also do this like NC 2C2 say for this. This is 2 factorial means n factorial n minus r factorial into r factorial. This is 2 factorial. 2 minus 2 is 0 into 2 factorial. 0 is what? 1. So we get here 2 factorial by 2 factorial. This is going to be 1. So this value is 1. Similarly for this value is 1. Now NC1 is equals to n or NCn minus 1 that is also equals to n. This is n that is 2 C1 or we can also say 2 C2 minus 1 is 1. This is again to be n. What is n here? That is 2. By substituting the value we will get this term at last 20. By substituting the value and solving this we get 25. So this is what? 2 plus 3, 5, 5 square is 25. So this is a binomial theorem by which you can solve this type of questions if they have a very high power. Now next is for any index, if n is any number that is positive, negative or fractional value, whatever the value of n, in that case we have two conditions. First condition is x is less than 1. Means its value lies between minus 1 and 1. In that case, we are going to use the formula 1 plus x raised to power n. That is 1 plus nx and so on. We can also put this formula like 1 plus x raised to power n by using the previous formula that is nc0 1 raised to power n x raised to power 0 plus nc1 1 raised to power n minus 1 x raised to power 1 plus nc2 1 raised to power n minus 2 and x raised to power 2 and so on. Now, this is nc1 is 1, 1 raised to power n is 1, x raised to power 0 is so going to be 1. So, this term contribute to 1. nc1 we know that is equals to n. This term is 1, this is x. So, it's this term is n, 1, x. So, this will be converted into this term. nc2. We can calculate NC2. This is equals to n factorial upon n minus 2 factorial into 2 factorial. We can write it as n minus 1, n minus 2 so on, that is n minus 2 factorial upon n minus 2 factorial into 2 factorial. So n minus 2 get cancelled with this. So we get what? NC2 is equals to n minus 1 upon 2 factorial. N minus 1 upon 2 factorial into 1, that is again 1, x square, so on. So this is the formula. Next, if mode of x is very less than 1. Now this is not going to be less than 1. This is very less than 1. In that case, we have formula. What we have to do? The formula is going to be again same. This formula. But we are going to do what? We are just going to neglect this higher term. We are going to just neglect this higher term. We have restricted our formula to this two terms. 1 plus nx. But there is a little bit change. If 1 plus x raised to power n, that is 1 plus nx. 1 minus x raised to power n, this is 1. It seems to be like what? This index is coming in front of this multiplication of this. So 1 minus x, so it's come here. So it is 1 minus nx. 1 plus x raised to power minus n, then this full term here, that is 1 plus minus n in multiplied with x, that is 1 minus nx. 1 minus x and minus n, if we take it here, that is 1 minus n into x, that is 1 plus n x. Now let's do an example. Expand using binomial 1 plus 3x raised to power 5 up to term having x cubed. So we are going to use the formula 1 plus x raised to power n, 1 plus nx plus n minus 1 upon 2 factorial x square n minus 1 n minus 2 upon 3 factorial into x cubed, so on. So by substituting the value one by one, like first of all 1 plus n into x. N is what here? 5. X is what? 3x. So next is n minus 1. N is 5. 5 minus 1. 2 factorial into x, that is 3x whole square. So on. And up to so on. But we have to find up to x cube. Up to this. So we we neglect the other term. We will just neglect them. And by solving this step by step, we will get the result this up to x cube. So this is the example of this. Now next second example is the acceleration due to gravity g dash at height h from the surface of the earth of radius r is given by this. And acceleration due to gravity at height h from the surface of the earth is given by this formula here. Now we have to do what? We have to find out the value of g dash using binomial theorem, where it is given that h is very less than r. H is very less than r, and where g is acceleration due to gravity on the surface of earth and r is the radius of earth. Now g dash equals to g r square. This is given in the question. Now we are going to do what? With this term h, we are going to multiply and divide r, because there is no effect on the result. If r get cancelled with this r, we again get the same thing. So we are doing a trick here that we are going to multiply and divide it with r. So r is here, r is also here. Taking r common, it's whole square bracket, so it's r square. 1 plus, so we are left with this r is common, this r is common. So we will be left with 1, and here we are left with h by r whole square, and if we take r outside of the bracket, it's whole square, so it's r square. This r square get cancelled with this r square, so we get g dash equals to g 1 plus h by r whole square. If we take this term from denominator to numerator, then there is always a change in the sign of power. Here power is positive. If we take it to the numerator, the power will turn to the negative. That is 1 plus h by r whole raised by minus 2. As it is given the question, h is very less than r. So dividing both sides with r, we get what? H by r is very less than 1. So this is according to the second condition, in which 1 plus x raised to power n is equals to 1 plus nx, or 1 plus x raised to power minus n is equals to 1 minus nx, but for the condition x is very less than 1. Here x is h by r. This is very less than 1, so if we apply this formula over here, that is 1 plus x is this. In next, this is n is minus 2 here. We are going to do what? 1 minus n minus 2 h by r, and g is f. So we get what? G dash equals to g 1 minus 2 h by r. This is the value of g dash by using binomial theorem. That's it. I hope the today's session is clear to all. If anybody have any doubt, please do comment, so I'll try to solve out your queries within a stipulated time. Thank you. Stay home, stay safe.